Morning, students. My name is Anusaya, and I'm going to teach you the first chapter of class 11th, some basic concepts of chemistry. This chapter deals with very simple and basic things about chemistry. For example, matter, solids, liquids, gases, etc. So, let's start the chapter. As we all know, the first thing which we have to study is matter. Now, what is matter? Anything which occupies space and has mass is known as matter. Okay, anything which has space, which occupies space and has mass is called matter. This you have studied in your younger classes. Matter can be divided into three types: solids, liquids, and gases. Okay, so what is the difference between solids, liquids, and gases? Solids are the substances in which the intermolecular force of attraction is very high. Okay, so in solids, suppose we are considering molecules, the atoms or molecules in solids are very closely packed. They do not have any space between them, or if they do have, then that is very, very less. In case of liquids, the gaps between the atoms or molecules can be seen. In case of gases, the intermolecular spaces are very large. Okay, this type of closely packed structure doesn't allow these molecules to move, but they do vibrate about their positions. In case of liquids, they can move freely. In case of gases, the movement is much more than that of liquids. In solids, we can say that the intermolecular force of attraction is very high. Okay, so what do you mean by intermolecular force of attraction? The force which keeps the molecules together is known as intermolecular force of attraction. So in case of solids, as we can see, the molecules are closely packed. These are closely packed because the intermolecular forces of attraction are very high. Now, next is liquids. In case of liquids, the intermolecular force of attraction is less than that of solids. As we can see from the structure, the molecules are not as close as the molecules present in solids, right? So in case of liquids, the intermolecular forces of attraction are less than that of solids. So this allows liquids to move freely. We all know that liquids flow. Why is it so? Because intermolecular forces of attraction are less. Okay. Next is gases. If we look at the diagram of gases, the molecules are far apart. This tells us that the intermolecular forces of attraction in case of gases, it is very less. This allows them to move more freely than that of solids or liquids. So, the intermolecular forces of attraction in case of solids is very high. For liquids, it is less than that of solids, and in case of gases, it is very less. So, the molecules of solid are therefore closely packed, and the molecules of gases are free to move about. They are not closely packed. So, the closely packed structures have fixed volume. Liquids do have a fixed volume. Okay, so when as solids are closely packed, their structure is retained and they have a fixed volume. In case of liquids, as I told you earlier, the intermolecular forces of attraction are less than that of solids. So this allows liquids to flow, but their volume remains fixed. Their volume has to be fixed and it also has to flow. So all liquids assume the shape of their container. Liquids assume the shape of their container. Liquids assume the shape of a container. Okay? Now, next are gases. They do not have a fixed volume. Okay? Since the intermolecular forces of attraction in gases are very less, so they can move freely, so they do not have a fixed volume. If you keep a gas in a small box, then it will be inside this, and if you fill this in a bigger box, then the molecules will occupy all the space inside the box. Okay, so we're summing up solids, liquids, and gases. Intermolecular forces of attraction are high. In case of liquids, it is less than that of solids, and in case of gases, it is very less. Solids are closely packed, liquids are not so closely packed, and gases are very free to move apart. And solids have fixed volume. Liquids also have fixed volume, but they take the shape of the container. Gases do not have a fixed volume. Okay? Now, after this, I was telling you about matter. Matter can also be divided into two types. First is mixtures. Second is pure substances. The matter in which the composition is not uniform, those type of matter or those type of substances are called mixtures. In case of pure substances, the composition remains fixed. For example, I'll take up one by one. Mixtures. A mixture contains two or more substances present in any ratio. A mixture contains two or more substances in any ratio. It can be 1:2 or it can be 3:4. Doesn't make a difference. Mixtures can be divided into two types. One is homogeneous mixture and the other is heterogeneous mixture. Okay. Now, homo, hetero. Homo means uniformity. So, homogeneous mixture is a mixture in which the composition of the mixture is uniform throughout. But in case of heterogeneous mixture, the composition is not uniform throughout. I will tell you with an example. Suppose you take a glass, fill it with water, and mix sugar. You can take salt also. Now, after mixing sugar in water, you will get a solution. You will get a sugar solution. If you take 1 spoon of sugar solution from this area or any other area you want, the amount of sugar in all these three areas will be equal. Or you can say the taste is same. Why is it so? Because the molecules of sugar mix uniformly in water. Either you drink it from this area or this area, the amount of sugar will be the same. Okay, so such type of solutions in which the composition is uniform throughout, these solutions are called heterogeneous mixtures. I'm sorry, these are called homogeneous mixtures. Now, I will give you another example. Suppose you have sugar and you have salt. You mix both of them. Okay, you have mixed sugar and salt. If you take 1 spoon from this area and 1 spoon from this area, then the amount of sugar and salt in both these areas will not be equal. Why is it so? This is because sugar and salt do not form a uniform mixture. So such type of mixtures in which the two components are not mixed uniformly, they are known as heterogeneous mixtures. Okay. Now, I told you that matter is divided into mixtures and pure substances. I classified mixtures into homogeneous mixtures and heterogeneous mixtures. What were homogeneous mixtures? The mixtures in which the composition is uniform throughout, and in case of heterogeneous mixtures, the composition is non-uniform throughout. Okay, now next I'm going to tell you about pure substances. What did I tell you about mixtures? Mixture contains two or more substances in any ratio. I said any ratio, but in case of pure substances, they are mixed in a fixed ratio. This ratio cannot be changed. Either you prepare a compound naturally or synthetically, the ratio will be fixed. So, pure substances can be divided into two types: elements and compounds. Okay, so what is an element? An element consists of only one type of particles. Okay, elements consist of only one type of particles. Whereas if you consider compounds, then two or more elements combine to form compounds. For example, if I say hydrogen, okay, so hydrogen is an element. There are so many elements: hydrogen, helium, lithium, beryllium, anything you can take as an example. So these are elements. If you take, suppose if you take a block of sodium, okay, if you take sodium, then this block, each and every particle of this block will be sodium. So that means what are elements? They consist of only one type of particles. Then what are compounds? Two or more elements combine to form compounds. Suppose if I take NaCl, what is NaCl? NaCl is common salt. Okay, so in NaCl, you can see that it contains sodium and it also contains chlorine. So sodium is an element, chlorine is another element. So when two or more elements combine, they form a compound. There are so many examples. Like you can say water. Water consists of two elements, hydrogen and oxygen. Okay, now these are compounds. Can you find another example? Something which you breathe out: carbon dioxide. Carbon dioxide has two elements, carbon and oxygen. Another example is calcium carbonate. Calcium, carbon, and oxygen. So calcium carbonate consists of three elements, so it is a compound. Next, we're going to study about the properties of matter. The properties of matter can be divided into two parts. One is physical properties. Second is chemical properties. Okay, as the word suggests, physical and chemical. Something which is related to the physical state of the compound, okay, and this is something which is related to the chemical properties of a compound. For example, if I have ice, okay, if I have ice cube, I supply heat, it will change into water, okay, it will change into water. Now, what did I change about it? Ice, the molecules are of water only. What is actually changed in this process? It is the physical state of matter that is actually changed. Like ice is a solid, okay? Water is a liquid. So those properties which only change the physical state of the compound, or which deal with only the physical state of the compound, are known as physical properties. Okay? For example, color. odor, melting point, or boiling point. Color. Color is something which we can see, right? If you look at something like, for example, you have salt. It is white in color, right? So this color is a property which you can actually see. Odor is something which we can smell, fine. And what about melting point and boiling point? Like I said, ice is changed into water, like ice melts. So basically, the physical state of ice has been changed to water. If I consider boiling point, then what is the best example for describing boiling point? I take water and then I supply heat. It changes into water vapor. So now the liquid state of water is converted into vapor phase. Okay, so this these are examples of physical properties of matter. What are the examples? Color, odor, melting point, and boiling point. Okay, now next is chemical properties. Okay, what do you deal with chemical properties is basically something which changes. Okay, so chemical properties means some reaction must have occurred. For example, if I have carbon or a small block of carbon, if I burn this in oxygen, I will get carbon dioxide. So this carbon is solid. Okay, now I burn it and I'm getting a gas. Once the carbon has been burnt and I get carbon dioxide, then this cannot be changed back. Okay, so basically in this process, a chemical reaction has occurred. So whenever you encounter a chemical reaction, then those properties are known as chemical properties. Okay, best example to describe is combustibility. Combustibility is basically combustion, like what I told you right now. Okay, so physical properties deals with the physical state of matter and chemical properties deals with the occurrence of a chemical reaction. Okay, now next is we are going to deal with some basic physical quantities. What are these basic physical quantities? First is length. Okay, the SI unit of length is meter. Second, mass. The SI unit of mass is kilogram. Next is time. The SI unit of time is second. The fourth one is electric current. The SI unit of electric current is amperes. The fifth one is thermodynamic temperature. The SI unit of temperature is Kelvin. Next is the amount of substance. Okay. Now, this will be something which is unfamiliar to you. It is known as mole. Okay. The SI unit of amount of substance is mole. I will explain mole later in this chapter only. Okay. And the last one is luminous intensity. Luminous intensity. The SI unit of luminous intensity is candela. Now, these are the basic physical unities: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. We mostly have to deal with length, mass, time, temperature, and amount of substance. Okay, the most important of this is amount of substance. Next, we're going to deal with mass and weight. Mass is the amount of substance present, or you can say the amount of matter present in a substance. Okay. Weight. Weight is the force exerted by gravity on an object. Okay. What is mass? Mass is the amount of matter present in substance, or you can say just simply amount of substance. And what is weight? Weight is the force exerted by gravity on that particular object. For example, our weight on the earth is different from the weight on moon. Okay. In moon, the gravity is very less, due to which our weight will be very less. So, but mass will remain same, whether it's on earth or it's on moon. So if I need to differentiate between mass and weight, then mass, first you have to define mass is the amount of substance. What is weight? Weight is a force exerted by gravity. Second, mass is always constant. It cannot be changed. But weight is not constant. It depends on the area. If the gravity is more, then our weight will be more, and if gravity is less, the weight will be less. So this is an important question. Differentiate between mass and weight. Okay? Now, next important topic is significant figures. Okay, so before starting significant figures, I need to tell about two words: precision and accuracy. Okay, suppose you perform an experiment in your laboratory. Okay, or I'll tell you another example. If you have a rope, okay, your class teacher gives you a rope, then she asks each of you to measure this rope using your own scale. Like you have a ruler or you have a scale. Then your teacher tells you to measure this rope. So suppose you have 10 students in your class. So 10 students will be having 10 different scales, and the measurements might vary. They can be same or they can be different. So if you measure the length of this rope, and 10 students will give 10 different values of the length of the rope. Suppose the length of the rope is 10 centimeter. Okay, so one student gives it like 9.6, another 9.7, another 9.9, some might give it 10.2. So the teacher has to select the most accurate answer. According to her, the correct answer is 10 centimeters. But none of the students of your class could get exactly 10 centimeters. So she has to take the best answer. What is the best answer? 9.9 centimeter. Why? Because this number is the most closest to the true value. The actual value is known as true value. So the value which is most closest to the true value will be the most accurate answer. Okay, so the other observations are not as accurate as 9.9. Okay, now I'll tell you about precision. I'll tell you with an example. Suppose you're dividing two numbers. Okay, two numbers. When you divide, suppose my correct answer is 10. Okay, so some might get the answer as 9.9. Going to the last example, 9.9 is the most accurate answer. Okay, what is the most precise answer? If one student gets it as 9.92, one gets it as 9.96. So the number of decimal places has increased from 1 to 2. Okay, if another student reports the answer as 9.78, so we have 3 decimal places. So as the number of decimal places increases, this brings us more closer to our actual answer. So the most precise value is the value which has more number of decimal places. Okay. Okay, now I'm going to tell you about significant figures. Significant figures are meaningful digits which are known with certainty. I'll give you an example and tell you. The first point, you will get the question as calculate the number of significant figures. Okay, what is the number of significant figures? At first, if I consider an example, first point is all non-zero digits are significant. All non-zero digits are significant. Like, for example, if I say 395, the number of significant digits in 395 is 3. How? 1, 2, 3. That's it. Very simple. And these are also non-zero digits. If I say 25, how many significant digits? 1, 2. If I have 1, 3, 9, 8, 7, 4, how many significant figures? 1, 2, 3, 4. 5, 6. Okay, so this is very easy. So all non-zero digits are significant. The second point is zeros preceding to first non-zero digit are not significant. Zeros preceding zeros preceding to first non-zero digit are not significant. For example, if I have a number 0.5, okay, this has 0. So what was the point? Zeros preceding the first non-zero digit are not significant. So what is our first non-zero digit? Non-zero digit is 5. So before whatever zeros lies before the first non-zero digit, they are not significant. So the number of significant figures in this number is 1. If I take 0.67, first non-zero digit is 6. Before 6 we have 1 0, so this won't be counted. Number of significant digits is 2. If I have 0.000789, then first non-zero digit is 7. So all the zeros before the first non-zero digit will not be counted. So the number of significant digits will be 1, 2, 3. Easy? Okay. Now, next is third point. Zeros between two non-zero digits are significant. Zeros between two non-zero digits are significant. For example, if I have a number 8.90075, so if zeros are placed between two non-zero digits, then they also have to be counted. Okay, so the number of significant figures in this particular number is 1, 2, 3, 4, 5, and 6. If my number is 2.075, now this 0 lies between two non-zero digits. So you have to count this also. So the number of significant digits in this particular number is 1, 2, 3, and 4. Okay. Next we have the next point is zeros at the end or right of a number are significant provided they are on the right side of a decimal point. Suppose you have a number 100. Okay? In 100, you cannot see a decimal point over here. So the number of significant digits will be only 1. If my number is 2000, you cannot see a decimal point in 2000, so the number of significant digits will be 1. If my number is 250, you do not see a decimal point over here, so the number of significant figures will be 2. But if I put a decimal point after 100, then let us count the number of significant figures 1, 2, and 3. Okay, if I say 2500 at decimal, then 1, 2, 3, and 4. If I write 250.0, Then this zero you have to count. Total number of significant figures will be 4. Like, what is the difference between this number and this number? In this number, you cannot see a decimal point, so we do not count this zero. Hence, only two significant figures are present. But in this number, you can see a decimal point over here. So whenever you encounter a decimal point, you have to count it. 1, 2, 3, and 4. Suppose your number is 2.0000. What are the number of significant figures? 1, 2, 3, 4, 5, and 6. Instead, if I do not put this decimal point and I write this number simply as this, then the total number of significant figures will be equal to 1. Okay, I hope this is clear. The next topic is dimensional analysis. Dimensional analysis is basically the conversion of one unit to another. For example, if you have a piece of metal, the length of this strip of metal is 3 inch. So you have to express the 3 inch in centimeters. Okay, how will you do it? It's very easy. First of all, you should know the relation between inch and centimeter. This you have to learn. 1 inch is equal to 2.54 centimeters. Okay, so if 1 inch equals 2.54 centimeters, then the length of 3 inches will be 3 into 2.54, that is equal to 7.62 centimeters. Okay, now this was very easy. I'll tell you another example. This won't be that easy, but still it's easy. You have 2 liters of milk. It's an example from the book. You have 2 liters of milk. Have to convert 2 liters of milk in units of meter cube. Okay, so how will you do it? First, you should know the relation between liters and meter cube. Okay? So, how will you derive the relationship between liters and meter cube? First, there's one relation which you need to know, that is 1 milliliter equals 1 centimeter. This is a standard relation. This you have to know. This you have to study. 1 milliliter equals 1 centimeter. Now, we also know 1 meter is equal to 100 centimeters. Okay, so if you cube left hand side and the right hand side, you will get 1 meter cube is equal to 10 raised to the power 6 centimeters. Okay, now 2 liters means 200 milliliters. Okay, now if 1 milliliter equals 1 centimeter cube, then 2000 milliliters should be equal to 2000 centimeter cube. Okay, now from this relation we can write 10 raised to 6 centimeter cube equals 1 meter cube. Then 1 centimeter cube should be equal to 1 by 10 raised to 6 meter cube. Okay, this is also equal to 10 raised to minus 6 meter cube. Okay, now come back to this. What do we have to find? 2 liters. I wrote that 2 liters are equal to 2000 centimeter cube. Okay, I also wrote 1 centimeter cube is equal to 10 raised to minus 6 meter cube. Now, this will be equal to 2000 into 1 centimeter cube. So, instead of 1 centimeter cube, I can write this. So, 2000 into 10 raised to minus 6 meter cube. I wrote this instead of this. Okay, now you will get the answer will be equal to 2. If we split this, you get 2 into 10 raised to 3 into 10 raised to minus 6 meter. Now, if bases are equal, then you have to add the powers. So 2 into 10 raised to 3 minus 6 meter cube. So final answer will be 2 10 raised to minus 3 meter cube. Therefore, 2 liters will be equal to 2 into 10 raised to minus 3 meter cube. This is our final answer. Okay, so how did we do this? First, we need to know the relationship between liter, milli, and meter cube. How do we calculate? We know this relation. Okay, then we know this relation also. These two relations, we derive this, then we know this, then we substituted the value of centimeter cube in this equation,